Welcome to the incredible journey of physics, where curiosity meets groundbreaking discovery. Today, we'll explore 5 turning points that revolutionized our understanding of the universe. From the smallest particles to the vast expanse of space-time, we'll witness the ingenuity and relentless pursuit of knowledge. Each experiment is a testament to the power of the scientific method, illuminating our path towards a deeper understanding of the cosmos. Let's dive in. Our story begins in 1887 with Albert Michelson and Edward Morley, who challenged the prevailing wisdom of their time. Imagine a universe filled with a mysterious substance called ether, thought to carry light waves. Michelson and Morley used an interferometer to detect this elusive ether. They reasoned that if the ether existed, the speed of light should vary depending on its direction through this medium. With meticulous care, they measured the speed of light in different directions, anticipating subtle shifts in its velocity. But the result? Nothing changed. The speed of light remained constant, indifferent to the direction of measurement. This null result sent shockwaves through the scientific community. The ether, once thought to be the bedrock of physics, was nowhere to be found. This unexpected finding set the stage for Einstein's theory of relativity, revolutionizing our understanding of space and time. Let's journey back to the early 17th century with Galileo Galilei, a towering figure of the scientific revolution. Galileo conducted rigorous experiments with inclined planes to study motion. He discovered that objects in free fall accelerate uniformly, regardless of their mass. This observation, known as the equivalence principle, challenged the notion that an object's motion was determined solely by its heaviness. Galileo's work laid the groundwork for Newton's laws of motion, cornerstones of classical mechanics. Our next stop takes us to the realm of light, and its baffling behavior. In 1801, Thomas Young conducted an experiment that altered our understanding of light and reality. Young shone a beam of light through 2 closely spaced slits onto a screen. If light were particles, one would expect 2 bright bands on the screen. However, Young observed an interference pattern of alternating bright and dark bands. This pattern could only be explained if light behaved as a wave. Young's experiment demonstrated that light waves could interfere with each other, producing regions of reinforcement and cancellation. This firmly established the wave nature of light, challenging the particle theory. Further investigations revealed light's wave-particle duality, a cornerstone of quantum mechanics. This duality shattered our classical intuitions, revealing a universe far stranger than imagined. As we venture deeper into the quantum realm, we encounter another pivotal moment in physics, courtesy of Albert Einstein. In 1905, Einstein published a groundbreaking paper on the photoelectric effect, earning him the Nobel Prize. When light shines on a metal surface, it can eject electrons, a process known as photoemission. The energy of these ejected electrons depended on the frequency or color of the light. Einstein proposed that light was a stream of discrete packets of energy called quanta or photons. This explanation resolved a major mystery in physics and provided evidence for the particle nature of light. Einstein's idea laid the foundation for quantum mechanics, altering our understanding of the subatomic world. Our final stop takes us to the cutting edge of modern physics, to the Large Hadron Collider at CERN. In 2012, scientists announced the discovery of the Higgs boson, a particle so fundamental it earned the nickname the God particle. The Higgs boson was the missing piece in the standard model of particle physics. This model describes the fundamental building blocks of matter and the forces that govern their interactions. The Higgs field gives particles mass, much like walking through a crowded room. The discovery of the Higgs boson confirmed the standard model's predictions and provided crucial insights into the nature of mass. It was a monumental achievement, showcasing the power of human ingenuity and international collaboration. From the ether's ghostly absence to the Higgs boson's grand entrance, these 5 experiments have shaped our understanding of the universe. They stand as testaments to human curiosity and the elegance of the scientific method. These experiments remind us that science is a journey, always pushing the boundaries of the unknown. As we stand at the precipice of new discoveries, the journey of physics is far from over. Subscribe for more deep dives into the wonders of science.